Okay, so here we're going to be looking at a continuation of our look at linear and nonlinear relationships. So when we look at these two tables, we have to figure out if they're linear or not. So remember, the first thing that we have to do is figure out, one, are the x's all going up by 1 every time? And in this case, they are. 2, what are the y's going up or down by? So when we look at this table here, all of the y's are going up by 3 every time. And if we look at this table, all of the y's are also going up by 3. So because they're all going up by the same thing every time, we would say that they are both linear. So now what we have to do is find the equation. So recall what we talked about previously, and that was here. So the first part of the equation is what do the numbers go up or down by? And the second part is what's the value of y when x is 0? So if we come back here, we can see that we're going up by 3 every time. And when x is 0, y is also 0. So we could say 3x plus 0, or we could just say 3x, which is more common. If we look at this one here, again, they're also going up by 3 every time. And if we look at the 0, we have a minus 1, so we can say 3x minus 1. Or remember, the other way of doing that was to test a point. So what's 3 times 2? 3 times 2 is 6. 6 minus 1 is 5. So that's how we can figure out what we add or subtract. So now what we're going to do is we're going to extend our work with patterns and extend our work with tables of values into what it might look like in a graph. So in the table, let's just go back for 1 second. Each of these 4 things is a coordinate. So this is an x coordinate and a y coordinate that represents a point. So we'd put a dot at -1, 3, at 0, 0, etc. So on our graph, we'd go -1, 3. Remember, left, whoops, that was wrong. And let's see here. It was -3, I think. Remember, we do x first and y second, so -1, -3, 0, 0, 1, 3, and 2, 6. And then whenever we graph things that are linear, which means they are aligned, we want to use a ruler. I don't have a ruler on my screen here, so mine isn't going to look good, but make sure that you use a ruler. The other thing that we do is we always put arrows on the ends just so that our line goes on forever in both directions. Sometimes when there's a context to the problem, it won't go on forever in both directions. So for example, if someone makes a certain amount of money per hour, we can't have negative time, so our graph will only have an arrow that goes up to the right, not down to the left. So it just depends, but usually if it's just a line that we're graphing, we'll have arrows in both directions. We're going to do the same for the second one. So again, -1, -4, so we go left, right first, up, down second, 0, -1, 1, 2, and 2, 5. And again, we get our ruler, and we graph both lines. So now we have to look at what is the same about both of these lines. So both of these lines, and this is going to be hard, I can't quite, I can show that. So you'll notice that they're both going up to the right. So they both have the same direction. We always read from left to right. You'll also notice that they're both going up by 3, which means they have the same steepness. And you'll notice that they're both linear. Oops. What's different about them? So when you compare them, there's one thing that's main difference, and that's that one line is 1 higher than the other. So this one, see, it goes through -1, -3. This is -1, -4. This is 0, 0. This is 0, -1. So if we look at it, we're going to look specifically at that point right there. That's a really special point. Both of those points are on the y-axis. And any point that's on the y-axis has an x-coordinate of 0. So this is 0, 0, and this one is 0, -1. That's a really special point, and there's a mathematical name for that point. And the mathematical name is called the y-intercept. And that is a really fancy word for saying where does a line cross the y-axis. In this case, it crosses it at 0. In this case, it crosses it at -1. If we come back up to our equation, we're going to notice those numbers. Here's our 0, and here's our -1. So now we can actually add something to what we looked at previously. This is what the numbers go up or down by. This is the value of y when x is 0. Now we know that this is that fancy word called a y-intercept, where the graph crosses the y-axis. This one had a fancy word that we learned called first difference. So now we've got some new language to add to some of the exploring we've been doing. So again, first difference was what we go up or down by. The y-intercept is where does that graph, so if we had a graph, where does that graph cross the y-axis? And it can be different for different graphs. So like my graph might look like that, and then it's going to cross there. That's called the y-intercept, and that's going to be important with the equation. So if we come back to here, the difference between these graphs then is they have different y-intercepts. So the ones on the left that go through 0, 0, these ones are special lines called direct variation. And all that means, it's a really fancy word for saying that a line goes through the origin. And the ones on the right are called partial variation. And that's just a really fancy word for lines that do not go through or don't go through the origin. So why is this important? Well, we can use these in all kinds of different real-world scenarios, and they can help us come up with formulas which will allow us to predict things like cost and things like that. So for example, we have a parking garage that's $2 an hour, which is probably, for Hamilton, probably reasonable. For Toronto, probably a little bit cheap. If we didn't park, we wouldn't be charged, right? If we parked for 1 hour, it would be 2. 2 hours would be 4, and 3 hours would be 6. So we could graph this if we wanted to. And when we graph, we would have a scale. So we'd have 1, 2, 3, 4. Let's say we'd have 1. So we always want to make a scale. So for example, 0 was 0, 1 hour was 2, 2 hours was 4, 3 hours was 6. We get our ruler, we draw our line. So here's an example of one where the arrow only goes in one direction because we can't have negative hours of parking. And we can look at our table to come up with the equation. We can notice in our table that we were going, up by 2 every time. We notice that our x, when x is 0, our y is 0, so our equation can be y equals 2x. We can then use that equation to answer the next question, which is, what if I park for 7 hours? How much would that cost? And that would cost $14. Then it asks us, is this direct or is this partial? So in this case, because we go through the point 0, 0, it is direct. So because it goes through the origin. So let's look at another scenario. So this particular scenario might make you hungry. Let's say we're at a restaurant and we're ordering like a small personal pan pizza. So the cost for this pizza is $6 plus $1 per topping. So within that scenario, we have a cost that's fixed. We have a cost that will never change, and we have a cost that's variable, that we will have a cost that changes depending on what we order. So the cost of the pizza will always be $6, regardless of how many toppings we order. And the variable cost is the $1 for the topping. So depending, if I only order one topping, that'll be $1, but if I order 3 toppings, it'll be $3. So that changes depending on how many toppings I order. So in this case, if I didn't order any toppings, I would still have to pay for the pizza. So that's going to be 6, but then each topping will be $1. So now I add that $1 on. So again, if we were to graph it, we might have, so here's 1, 2, 3, here's our toppings. There's our cost. So 0 toppings costs $6, 1 topping costs $7, 2 toppings cost $8, 3 toppings cost $9, and our graph's going to look something like that. In this case, again, our equation, if we look at it, we're going up by 1 every time, but our value of x when y is, our value of y when x is 0 is 6. Or we look, our y-intercept is 6. So we're going to get 1x, or x, plus 6. Notice that our variable cost, 1, went with the x, and our fixed cost is $6 for the pizza. Notice that that one came after the equation. So now we can use our equation. What if we ordered a pizza with 7 toppings? That would cost us $13. And is this direct or partial? So because it goes through 0, 6 and not through 0, 0, we call this partial variation. And why? Because it does not go through the origin. Oops. So these are just a few new words to build our understanding of relationships that are linear. So now we've learned about how can we tell if something's linear or not. How can we find the equation? We've learned about how we could graph using a table. And we've learned about the difference between partial and direct variation, and we learned a new word called the y-intercept.